You're still on the same problem?
Yeah, it's taking so long. I wish there was a shortcut.
There is! It's called the product rule.
It's time for calculus.
Dom is the coolest. He will teach you math. Dom is the coolest. He will teach you math. Professor Dom.
It's Professor Dom, and I'm here to teach you today about the product rule. So over here, I'm sure when you've been given equations to find the derivative of, you've been like, oh my gosh, these products are so confusing, how am I going to combine them together? And especially when you get something like that, that's that gross, you're not going to want to look at that and combine them all. So there has to be a better way, right? And what does this little math guy think? He says, yes, there is a better way. That's why his mouth is getting larger. Okay, so let's find a better way to do this. Let's set Dom of x equal to f of x times g of x. Now let's use the definition of derivative and plug that in there. So here we have our just regular definition of derivative, where you take the limit of that big gross thing right there. So let's see if we can do anything to simplify it, and there is a way to do that, and what we want to start with is starting by adding something in which we could be able to factor out some of these guys. So but you can't just add something in without subtracting it again. So let's add this guy in and subtract it. So right there we have it. We have added in f of x plus h times g of x, and then you subtract this gross looking thing right here because I ran out of room, which is just the same as this thing, which is f of x plus h times g of x. And some of you might be wondering why we did that. This is just good so we can be able to factor out the g of x and the f of x plus h. So let's go ahead and do that. So we can see here we factored out the f of x plus h from here and here, and we've added what those two are being multiplied right here, and then we've taken the g of x out of this one and the g of x out of this one and combined those together. So now we know that since this is all over 1h, we can split this up and take the limit of both sides. So now we have that, we can see that the limit is taken on both sides, and since there's just a plus in the middle here, we can split this fraction up into two separate fractions and take the limit of each. And since we did that, now we can just take out the g of x of this one and get rid of it from the fraction at all, and take the f of x plus h and get rid of it from that fraction. So now we did that, they're not connected, and we can do that just because it's multiplication there. And now let's take the limit of some of this. So we know that the limit of f of x plus h, that alone, that limit, as h approaches 0, is just f of x, because when we plug in 0 for h, that becomes regular f of x. Now, what do we do with the right guy here? Here it's g of x plus h plus g of x over h, and that looks oddly similar to our equation for the derivative of g of x. Looks similar because that's what it is. That's what it is, so we can just plug in g prime of x right there, and we add here this side. G of x is just g of x, there's no h to even change in that one. So g of x times, what is this? This is our equation of derivative, but instead it's for f of x right here. So now we know that that is f prime of x. And what? This looks so nice. This is such a nice guy right here. This is actually our final equation for definition of derivative. Now that we've solved this handy-dandy formula, I'm sure some of you are wondering what to do with an extra factor if we have something like d of x. So let's do the proof again, but with another d of x. Wow, that girl is getting shocked. No, we're not gonna do that. what you do, it's pretty simple. I'll write it out down here. So here's our equation for if we have 3 factors. And some people are going to want to try to combine this in. They're going to want to take the d of x and then just merge that with the g of x. And that is
wrong.
That is absolute
Wrong.
Proved.
We're not going to want to do that because a lot of times you'll make mistakes, or it's such a complex factor that you don't know what you're doing and you can't mix them together, so you're going to want to use this equation. That's a common mistake right there. So it's a pretty simple equation. You can see the pattern pretty easily. It's f prime of x times g of x times d of x plus f of x times g prime of x times d of x plus f of x times g of x times d prime of x. So what you do pretty much is with every factor you find the derivative of it and you multiply it by the other factors, and then you add that with all the other derivatives multiplied by the factors. So there we go, that's how we do it with 3 factors.
Okay, now we'll try it one more time with e to the x, because e to the x is a special one with a special rule that I like to use for it. So let's get going. Okay, so first we find the derivative of e to the x. What is the derivative of e to the x, you may ask? It's e to the x. Special guy, you are. Multiply it by pi times x squared plus pi, and we add e to the x times the derivative of this. And we get that. Now, a dumb thing people do is they leave it just like this, or they try to further factor this down.
Morons.
But the best thing to do is see that e to the x is in both of them, and that we can just factor out the e to the x and leave those together, like this, like so. And there's our final answer. You can just leave it like that if you want. And something I like to remember with e to the x is just when you have an e to the x, you can just take an e to the x and multiply it by this plus the derivative of that, and then you have your answer. So it's a pretty easy way to do that.
Dom Productions.